Good morning. All right, good morning. Hope you guys are doing well. Happy Thursday. Couple of announcements. There is no school Monday. So no school Monday. There won't be any classes. So hope you have a nice 3-day weekend. Also remember that exam P3 is tomorrow morning at 8 o'clock. So make sure that you have all your alarms set and that you're not late for that exam. Make sure you submit your scratch paper to classroom. Also on Tuesday morning at 8, hopefully that's going to be an easier exam. That's P4. So I'm hoping you guys all get an A on that one. I'm hoping that you do well on P4. That'll be one of the easier reviews. Today I'm planning on giving you a very, very important factoring. And so I'm going to be going over 7 factoring methods. And I'm going to give you really, really good notes on that. Factoring is something that's really important in your future math classes. Hopefully you learned it in Algebra 1, but I'm not going to assume that. So I normally don't go over it in pre-cal, but it's very important that you know it. So I will teach it. So first of all, though, I'm going to take some final questions on P3 or P4. So if you want to ask me any questions for, especially the exam tomorrow, feel free to ask me.
Can you do number 31 on P3?
31?
Yeah.
I'm not going to give you anything that hard. So remember, on the test, I only give problems on the first 4 or 6 problems. I don't give the ones at the end. So after this, if we could just focus on, some of the basic stuff. Let's try not to do the hardest problems because I do have this lesson I have to teach. All right, what you want to notice is you can simplify this right away. And we always want to simplify whenever possible. So these trailing zeros always cancel. It's like dividing by 10 on the top and the bottom. So when you do this would be the square root of 20. And the rule with division says you keep the base and subtract the exponents. So now I'm going to do a prime factorization on 20. So I'm going to take out a 5 times 4 is 20. 2 times 2 to be 2 times 2 times 5 times x to the 4th. So remember, you have to have a pair for one to come out. And you can either write that out, x times x times x times x. You can just write x squared times x squared, because whenever you have the index of 2 matching a power, 1 gets to come out. So for example, if you have the cube root of x cubed, an x comes out. If you have the 5th root of x to the 5th, an x comes out. So in this problem, a 2 and 2 x's come out. So your final answer is 2x squared times radical 5. I'm not giving you anything this hard. Okay, other questions about any of the other problems that aren't the hardest problems in the book? Is it okay if you guys want to ask me about this one, or is it okay if I erase it? Okay, I just want to say it's nice to see all of your faces. Thank you for having your video on. I really appreciate that. I like to know you're with me, so thanks. Go ahead, I'm listening. Other problems, questions? Are you guys going to ace this thing?
Hell yeah.
Yes, of course you are, because you're so smart. Let me show you a problem. What do you think about this one? Now, remember I said you can't have a negative under an even index? But I don't really have a negative, do I? Watch. Isn't this -1 times 2 to the 4th? And didn't I say that a negative raised to an even power is positive? Yeah? What about this one? The square root of -4. What's that answer?
No real.
Can't have an even index and a negative under there. So this one, this was an even index, but that negative went away inside the radical. It went away inside it. Okay, other questions? Can I erase these?
Yes.
Okay. Now remember, today or tonight when you study for this exam, make sure you work a lot of problems because you're trying to build your confidence. So the more problems you work correctly, the more confident you're going to be when you sit down. Okay, would anyone like me to work any more problems in P3 or P4? You guys are going to do good then, hopefully. All right. This is a tiring lesson, but this is going to help you a lot. If you're obviously planning on going to college or planning on, taking more math classes, I put this in your material section. So this right here are 7 factoring methods. And I'm going to go over each one of these. I normally don't do this in pre-cal, but I'm not going to assume you know it. And so I'm going to go over these 7 factoring methods right now. If you can print this out, that would be beneficial to you. Also, on 3, 4, and 5, those are special cases. So if you could put those in a box and say that those are special cases, that would be good. Now, this assignment in P5 is not going to be out of the book at first. They're puzzles. So see all these puzzles I have of all the different factoring methods. So this is how we're going to start out before I give the book work. All right, now, the other day I went over the greatest common factor, right? Right? We went over this the other day, is that correct?
Yeah.
All right, I'll work one more problem on this. The greatest common factor is, it could be any number of terms. So it could be 2 terms, it could be 3 terms, it could be 4 terms, it doesn't matter. So if you had something like 6x cubed minus 9x squared plus 12, that is a cubic trinomial. So you would build a cake and find out what's common. In fact, I'm gonna put an X there. So you're gonna look at the numbers and the variables and tell me what's common. So what's common with the numbers and the variables?
X.
3x.
Yep, there's an X. There's an X in all of them, right? Okay, what else?
3.
Yeah. And remember, the way I'm teaching this, if you miss one, you can recover by building another layer. All right, here we go. 3x, now remember, we're not taking out a prime number with this. We're just taking out the greatest common factor. So 3x times what is that? 2x squared? 3x times what is that? Negative 3x? And 3x times what is that? Wouldn't that be a 4? And so what you do is you look at all these and go, oh, I got them all out. So you realize what you did? You did the distributive property backwards. So this multiplies to give the original problem. 6x cubed minus 9x squared plus 12x. So you did the distributive property backwards. Now, if you do have to build another layer, make sure that whatever you bring out, you multiply whatever you have in front, multiply. Now, I did work a couple problems like this the other day, right? So I can go on. Okay. That's the GCF. Oh, and I think I told you, you always do this first. So in every factoring problem you have, you always you train yourself to do a GCF first. All right, let's go on. I think I also went over grouping, but I'm going to do a couple problems. So the second factoring method is grouping 2 by 2. And this guy has 4 terms. And remember, you always want to do a GCF first, if you can. So we try to do a GCF, nothing, no X's, no nothing. So we're going to build 2 cakes and take out the greatest common factor of each. So in this one, what's common is there's no number, well, 1, but x squared gets to come out. So x squared times what is x cubed? X squared times what is that? 3. Then you go to the next cake. We can take out a 4. 4 times what is that? X. 4 times what is that? Now the cakes have to match. So if these cakes don't match, you have to switch the terms and try to factor. So the cakes do match, which means we're going to use one of the x plus 3s, and the other part is x squared. And that does multiply to give the cubic. So FOIL method backwards. I'll do one more of these. All right, so the first thing you do is a GCF. And there's nothing coming out. The factors of 14 are 2 and 7. Can't do a GCF, so we're going to build 2 cakes. So what can come out of the first cake? A 7x squared. So 7x squared times what is that? 2x. 7x squared times what is that? -3. Now check this out. When you try to, you can't take anything out, but you have to take something out the way I'm teaching it. So if I take out a 1, that's going to be -2x and the cakes aren't going to match. So let's take out a 1. Let's take out a -1. So a -1 times what is that would be 2x. And a -1 times what is that would be -3. And voila, the cakes match. So what would your answer be? Go ahead, I'm listening. What would the answer be?
7x squared minus 1
Times.
and 2x minus 3.
That is correct. And we just did the FOIL method backwards. Can you imagine my high school teachers just telling us to guess? Like, just guess that. Yeah, good luck. Okay, so do you guys want to ask me while this is up here? Any questions about grouping 2 by 2? All right, the next one is a special case. It's called the difference of squares. Difference means subtract. And this guy, he only has 2 terms. So if it doesn't have 2 terms, don't try it. Okay, so for example, there's a minus, and those are 2 squares, because isn't x times x x squared? And isn't 2 times 2 4? So what you're going to do is you're going to use this template. Now, when I say template, I mean you're always going to use this. So last period, people were like, why is that a plus or minus? Because that's what you do. That's the template. So I don't care what problem it is. If it's the difference of squares, you're always going to do this pink. All right, here we go. So this is a square, and 2 squared is 4. So guess what the answer is? Pretty easy. So remember, you do a GCF, you can't. This looks like the difference of 2 squares, and if it is, you're going to write it as the difference of 2 squares, which is the product of a sum and a difference. So what do you get? X and 7. So guess what your answer is? That's the sum of 2 squares, right? Can't be factored. So you just circle it, cannot be factored. That can be factored. So you're gonna get so good at this, you'll be able to do this in your head. Like, oh, the difference of squares, x 5 times x minus 5. X squared minus 100, x plus 10 times x minus 10. So what would you put in? What's this one?
5.
So what's your answer?
X plus 5 and x minus 5.
So this one, you probably had it, and you could probably do this one in your head when you see it. Okay, the next one is a special case also. It's factoring method 3. I'm sorry. So we greatest common factor, that was 1. Grouping 2 by 2, difference of squares. This is factoring method 4. These are perfect square trinomials. Try means 3. So these are 3 terms. And this is a special case. So you try to do a GCF. It's not grouping. It's not the difference of squares. This is what you want to look at. Those are perfect squares. So what you're going to do is off to the side of your paper, you're going to do a 3-step test. Now, students usually ask me, is it always a 2? Yes. Is it always squares? Yes. It's exactly this. So watch what I'm going to do. I'm going to look at the first one. It is a square. I'm going to look at the third one in descending order, and the third one's a square. So I'm going to take the x and the 10 and put them in there, and I get 20x. Look at that. That matches the middle term. It passed the test. And since it matches the middle term, it's going to be this. Oh, I want to do that in pink. I'm sorry. Since it matches the middle term, it's going to be the square of a sum. And you're never going to guess what the numbers are. This is an x10, x10, x. So that is a special case. And if it passes the 3-step test, then it's a perfect square trinomial. This is the one that teachers don't normally teach because they don't realize how much you're going to use it in higher level math classes on a problem like this. This is a nasty problem, a lot of big numbers. So the factors of 25 are 5, so there's no GCF, not grouping 2 by 2, not the difference of squares. It looks like it might be a perfect square trinomial. Look at this. So we're going to do this test. First, last, 2 times those. And see what we get. So 25, isn't that 5x times 5x? And 9 is 3 times 3. So we put a 5x and a 3 in. And we get positive 30x. Doesn't match it. But look, doesn't it just vary by a negative? So it'd be the square of a difference. So if it matches the middle term perfectly, it's the square of a sum. If it differs by a negative, it's the square of a difference. That's it. If it doesn't look like it at all, then it's not a perfect square trinomial and you try to do another method. So this answer is 5x minus 3 quantity squared. And if you multiply this out, you will get the original. That's a FOIL. All right, do you guys have a question about this one? Can you guys respond to me? Are you following these or
Yes.
had them?
Yeah.
Okay. Yeah, don't ever throw these notes away. I have a lot of former college students that always say, gosh, people have purchased my notes. Like at RCC, students have asked, where'd you get those notes? And the students will say, I got them from my math teacher in high school, and they actually pay for them. So make sure you keep these notes around because they'll be useful to you, especially these factoring notes. Okay. The next case is factor method 5, and it's the form x squared plus bx plus c. It is a special case. I'll tell you why, but this is 3 terms. And the reason why it's a special case is because that's a 1. So for example, can't do a GCF. It's not grouping 2 by 2. It's not the difference of squares. It's not a perfect square trinomial. I think it's this one. So the reason why I think it's this one is because there's a 1 in front. And what you're going to do is you're going to multiply 1 times 6, and you get 6. So off to the side of the paper, you're going to multiply to get a 6 and add to get the middle term. Now, your teachers may have taught you another way. I don't care how you do it. Just do it correctly. This is for people who didn't get it the first time from the teacher who tried to teach all kinds of different ways. So what happens here is you write down all the factors that multiply to give 6. Well, it's kind of like a puzzle because not only do they have to multiply to give 6, they have to add to give 5. And there's only going to be one combination that works. So we're done. You always put x's, and all you do is put the in there. That's why it's a special case. Let's do another one. Let's do one with a negative 5x. So once again, you try to do a GCF. It's not grouping. It's not the difference of squares. It looks like factor method 5. So 1 times 6 is 6. So you want to multiply to get a 6 and add to get the middle term, which in this case is a negative 5. So you have 1 times 6, 2 times 3, 3 times 2 is wrapping around, so you can stop. Now think about this. How do you multiply to get a positive but add to get a negative? Wouldn't both of these have to be negative? Remember, it has to work in both. So this is a negative 2 and a negative 3 for a negative 5. So we're done. So you just put the factors in, x minus 2 times x minus 3. Match your answer. Now, sometimes with factor method 5, you can just guess these. So if you get really good at this, you can just go, what multiplies to give 6 and adds to give a negative 5? What multiplies to give 6 and adds to give a positive 5? So if you can guess quickly, fine. I'm just showing you a systematic way of doing it if you can't guess. Did any of your teachers teach another way? Did any of your teachers not teach this?
No.
Really?
Nope.
All right. It's okay. I got you guys. I got you. I'll take care of you. Okay. Do you guys want me to work another one of these with like, see what I taught here? I taught a plus plus and a minus plus. There's a couple I haven't taught, like a minus minus. Do you want me to do another problem?
Yeah.
Yes, please.
This is a minus minus. So you try to do a GCF, no. Grouping, no. Different squares, no. Perfect square trinomial. With a perfect square trinomial, you can't have a minus here. So you cannot have a minus. You guys, I need you to focus as much as possible. Because I know there's a few of you right now that aren't really paying attention, and I really need you to pay attention because this stuff is important and it's part of something way bigger. So I really need you to focus in on what's going on. All right. So there is a 1 in front, and this is a special case. When you multiply, you get -6. I'm going to multiply to get a -6 and add to get a -1. We go through this and we write down the factors that multiply to give this. And now to multiply to get a negative, one of them has to be negative. Well, doesn't the bigger number have to be negative in order to add to get a -1? See, you have to multiply to get a negative. So that means this is either going to be a positive negative or a negative positive, and the bigger number has to be negative to add to get a negative. So the answer is x plus 2 times x minus 3. And if you FOIL it, you're going to see that it equals what we started with. So we did the FOIL method back. Okay, do you guys want to ask me any questions about this one?
No.
Okay, this right here is factoring method 6, and it's not that it's hard, it's just tedious. Okay, this is form ax squared plus bx plus c. And it's like number 5, but it's more work. The reason why this is different is because this is not a 1. So this one's a pain. So you try to do a GCF, you can't. It's not any of the methods we looked at. It's factoring method 6 of that 3. So what you have to do is multiply like we did in 5. So 4 times 3 is 12. And we want what's going to multiply to give a 12 and add to give 8. So 1 times 12, 2 times 6, 3 times 4, 4 times 3, we stop. Now, in order to get a positive, they're either both positive or both negative. In this case, we have to add to get 8. And here it is. Now here's the problem. You can't write the answer. So what you have to do, unfortunately, is bring these guys straight down, and you have to split up the middle term. Now, the middle term are these factors with the variable. So this is going to be 2y plus 6y. So see the factors go in there? And notice that this adds to give the middle term. So these add to give the middle term. So we're going to build two cakes now, and we're going to have to do grouping 2 by 2. So you're going to take out a y. That would be 3y. Y times what is that? 2. This one you can take out a 2. 2 times what is that? 3y. 2 times what is 4? And do the cakes match? Hold on, that's not right. 2 times 2. The cakes match, right? So your answer is y plus 2 times 3y plus. So it's not that this method's hard, it's just a pain. It's just time consuming. Because in number 5, you can write the answer right away. On this one, you can't write the answer. You have to do this grouping. It's a real pain. So that's why I made it number 6, so it'd be the last one you choose. I'll do another one of these. All right, you cannot do a GCF on this, even if you try. Doesn't work. You try all the other methods, nothing works. It's not a perfect square trinomial. So unfortunately, it's factoring method 6, I think. So you want to multiply these guys. And I think that's 96, 12 times 8. So you want what's going to multiply to give a 96 and at the same time add to give a negative 35, the middle term. Okay, you might have to help me with this. These are numbers I don't know about. So you have 1 times 96. You have 2 times, what, 48? 3 works. 3 times 32. Does 4 go into 96? Can you guys, does 4 go into 96? Somebody. You guys have a calculator, help me out. 4 times
24.
Okay, 5 doesn't work. 6, I think is gonna work. See, this is a pain. Goes in 1, 3, 6 times what? 13? No. Does 6 go into 96?
16.
Thanks. And so it's like, I'm sick of doing this, so I'm just gonna try this out. Now, since they're both positive, since this is positive, you're either multiplying 2 positives or 2 negatives. And since you have to add to get a negative, they're both negative. Now, people were really confused about that last period. So if you have a question, ask me. Now here it is, look at it. It's -3 and -32 add to give -35. Only one's gonna work. So thank goodness we found it. So you're gonna bring down the 8y squared and the positive 12. And you put the factors in for the middle term. So this is gonna be -3y and -32y. And now you're gonna group. So on the first one, all you can take out is a y. So you get 8y minus 3. And on the second one, I want to take out a negative. And I'm going to take out a -4. Hopefully the cakes match. A negative times a positive 8, that worked. and a negative times a negative 3, yes, the cakes match. So the answer is y minus 4 times 8y minus 3. Remember, the cakes have to match. If the cakes don't match, you have to regroup. So see how this works? This is why we don't like factoring method 6. Okay, do you want to ask me any questions about how I'm doing this? Hello?
No, I'm
Hello?
good.
No.
You guys are okay?
Yeah.
Yeah.
Okay, I'm sorry this is so long and drawn out. I'm worn out too. At least you don't have to teach this twice. Okay, one more factoring method and we're done. This factoring method is actually algebra 2. So those methods you just saw, that was all algebra 1. Okay, this factoring method 7 is the sum and difference of cubes. So it's the only other one that has 2 terms. And notice that we didn't have a sum of squares, but we have a sum of cubes. So watch this. Can't do a GCF, not the difference of squares. So check this out. This looks like the sum of 2 cubes. And if it is, this is weird. This is going to be a binomial with a plus, and this trinomial is going to be minus plus. And somebody said, well, why? And the answer is, this is the rule. So, that's an x, that's a 2. X times x times x, 2 times 2 times 2. This is x plus 2. What goes here is a square, and this is also a square, and the middle term is the product, and that's the answer. Let's do another one of these. Can't do a GCF. It's not this, there's no sum of squares. So it looks like the sum of cubes, so test it out. If it is a sum of cubes, it's a binomial with a plus, and this is minus plus. And the way I memorize it is the minus doesn't make sense. That's how I remember it. So this would be y times y times y, and that's 3 times 3 times 3. So help me out. What do you think this is? What do you think goes?
Y plus 3.
Yep. What's this? You square it.
Y squared.
Yep. And this would be 3 squared, which is 9. And then the product is 3y, and you're done. So let's see what the difference of cubes looks like. can you guys, it's okay? Because there were people complaining yesterday that they couldn't see the boards.
Yeah, it's good.
Yeah.
Yeah, we see it.
Okay, thank you. All right, check this out. So that's not the difference of squares, and it's nothing else. It looks like the difference of cubes. So what you're going to do with this one is you're going to do the difference of 2 cubes, and the answer is going to be a minus plus plus. And how I remember this doesn't make any sense whatsoever, but that's the rule. So this is A times A times A. And this cube is 4 times 4 times 4. So you get A minus 4. What do you think goes here? A squared. 4 squared goes there, and the middle is 4A. Okay, I have one more to show you. This one's a little different, and people have a tendency to mess this up. Can't do a GCF even though you try. You skip all the way down to the difference of cubes, and you hope that it is. So is this the difference of 2 cubes? If it is, it's a binomial and a trinomial plus plus. And I always write those down so I don't have to think about it. All right. Isn't this 2x times 2x times 2x? And this is 3 times 3 times 3. So this part's easy. 2x minus 3, but watch this. Isn't this 2x quantity squared? So wouldn't that be 4x squared? And people like to write 2x squared here. This is not 2x squared. This is 4x squared. That's 9. And what goes in the middle is 6. So don't mess this up. When you have a monomial, it's a product, make sure you deliver the power across the product. Now, I did not say deliver a power across the sum. I said deliver a power across the product. Okay, that's it for the factory methods. Do you guys want me to do any more examples of any of them?
Can you do one more?
Yeah, of which one?
The sum of cubes.
So we don't have a sum of squares, and that's the GCF. So we're going to test for the sum of cubes. if it works, it's going to be a binomial with a plus minus plus. It's always that. So what you have here is 5 times 5 times 5 is 125. And 8 is 2 times 2 times 2. So this part is 5y plus 2. What's 5y quantity squared?
25 y squared.
That's correct. 2 squared is 4, and the product of those two is 10y. And then don't try to factor that because you're not, you won't ever be able to accept ooh. Is that factor? Most of the time, those trinomials do not factor. This looks like it does those. Let me try this test. It looks like a perfect square trinomial. So that's 5y, and that's 2. 5y and 2. See how that's 20? So it failed. So it can't factor. The majority, 99.9% of the time, those trinomials don't factor. So see, it failed on the last step because it was 20y. It didn't work. So what I'm trying to say is you don't have to try to factor those trinomials. They usually never work except in higher level classes where they're more complicated. Right now, those are never going to work. See, because you have to factor completely. So if you might have to factor this, you might have to, there's problems where you might have to factor more than once. I'll show you what I'm talking about. Okay. So I know that looks like the difference of squares, but remember you have to do a GCF. So you can do a GCF, so you have to. After you do a GCF, look what you have. You have the difference of squares. So you have to factor completely. So what happens with this 2 is he just floats down, and this would be x, and that would be a 4. So this would be 2 times the quantity x plus 4 times x minus 4. So I had to factor twice in this problem. I had to do a GCF, and then I had to do the difference of squares. So just remember, you have to factor completely. So let me just tell you what's going to go beyond this. This is a quadratic. And later on when we solve it, we're going to say that we broke this quadratic down by factoring, and we're going to say that this quadratic crosses the x-axis at -4 and 4. So what makes this 0, -4? What makes this 0, 4? That means this quadratic, this graph, is crossing the y-axis at 4 and -4. So that's how the factoring is going to help us out at first. We're going to solve the quadratic by factoring. But not all quadratics are solvable by factoring. The problems have to be perfect in order to be factored. All right, do you guys want to ask any more questions about the factoring methods? Okay, well, we have some time. Class is over at 12:10. What I'm going to do is I'm going to post these puzzles. So I'm going to go in and post these puzzles. This will be the next assignment. Well, this is called the factoring puzzles. So I'm going to put this paper, which is very important. I'm going to put materials, and I'm going to put these puzzles. It's one packet. I'm going to put these puzzles in for your assignment. It's called lesson puzzles or factoring puzzles. Factoring puzzles. Okay, so what I'd like you to do is you're going to start with the first puzzle in your teams, and you're going to work through there. I'm available on the Remind app if you need me, and you're going to go to those Math Wizard teams that you were in the other day. Okay, so I'm going to go into Google Classroom and post this, and you should be able to see it. I'm going to take attendance in those teams, so I'll see you in there. Thank you so much for hanging in there with me. I know that was a really long lesson. I'm going to turn the recorder off, and I'll see you in the teams, and I will post that puzzle assignment.